Hello, Year 8. This is the solution to Week 18, Recall and Retrieve. I will be going through the first 4 questions. If you are here for the answers for questions 5 to 8, then if you have a look in the description below, there will be a timestamp that will take you directly to the solutions to question 5 onwards. So, looking at question number 1. Question number 1 is some angles in parallel lines. If I look at x is an obtuse angle, 107 is an obtuse angle. Both of these angles are 107. The reason being, if I draw in the arms of the angle, it is a Z shape, and a Z shape is what we refer to as alternate angles. Question number 2 is a function machine. The function machine is timesing by 4 and then subtracting 9. It says, what is the output when the input is 8? So if I put 8 in, 8 times 4 would be 32. And then 32 subtract 9 would be 23. For the second part of the question, it says, what is the input when the output is 3? So I need to use some inverse operations here. Working my machine backwards, the inverse of subtract 9 is add 9. And the inverse of times by 4 is divide by 4. So popping 3 in, 3 add 9 is 12. And 12 divided by 4 is 3. For question 3, we have got a multiplication with decimals. Now, the approach that you should be taking for a multiplication with decimals is to ignore the decimals, perform a long multiplication using whichever method you prefer. I much prefer the traditional method, getting a solution, and then popping your decimal point back in your answer. So on this top line, I'm going to do 294 times 7. So 4 times 7 is 28. 9 times 7 is 63. Add the 2 is 65. And 2 times 7 is 14. Add the 6 is 20. On the next row, I'm doing 294 times 30. Or, with our little trick, drop a 0 and do 294 times 3 with a 0 on the end. It is then equivalent. So 4 times 3 is 12. 9 times 3 is 27. Add the 1 is 28. 2 times 3 is 6. Add the 2 is 8. If I add these up, I get 8, 7, 8, and 10. So the answer to this, 2.94 times 3.7, must have the exact same digits. There's now 2 ways to decide where the decimal point is going to go. You can either count the decimal places. I need 3 of them. Or, as I prefer to do, use approximation. This number's nearly 3. This number is about 4. 3 times 4 is 12, but that would be a slight overestimate. So to make this number approximately 12, the decimal point is there. In question 4, it says work out the shaded area. We have a rectangle first. Rectangle will have area 14 times 8. 14 times 8, I believe, is 112. For the triangle, did you remember to half it? It's 3 times 4 divided by 2, which is 6. When we subtract those, the area of the shaded section is 106. These are the solutions for questions 5 to 8 for Recall and Retrieve Week 18. So question 5 is all to do with a little bit of BIDMAS and using a bit of powers. The square root of 225 is 15. 3 squared is 9. So 15 add 9 is 24. 2 cubed means 2 times 2 times 2. And that is 8. Negative 5 squared is negative 5 times negative 5, which is positive 25. And because this square root runs the whole length of the calculation, I've got to do this calculation first. I've got to do 10 divided by 2, which is 5. I've got to do 105 take away 5, which is 100. And then it's the square root of 100, which is 10. Question 6 is expanding brackets. When you expand a bracket, you just multiply everything in the brackets by the number outside. So 9 times 3x is 27x. 9 times 4 is 36. 6 times 7a is 42a. 6 times negative 2b is negative 12b. And this one's a little bit trickier. An x times an x is what we call x squared. And an x times the 5 is plus 5x. Question 7, we've got a probability scale. The probability scale has been split into 6. So each of these lines is an increment of 1/6, which makes sense because this is a question to do with rolling dice. Rolling a 7 on a dice is impossible. So that is at 0. Rolling an odd number on a dice. Well, there are 3 out of 6 outcomes that are odd. So that is equal to a half. Rolling a number that is less than 2 on a dice, there is only one number less than 2, and that is the number 1. So that is 1 out of 6, 1/6, which is C. Finally, question 8 is an equation with unknowns on both sides. The first step when dealing with an equation with unknowns on both sides is to try and reduce it to an equation with unknowns on one side. And I can see if I've got 4y's on one side and 2y's on the other side, I can knock 2y's off both sides of the equation, and it becomes 2y plus 19 equals 3. Now that I have isolated the y in one place, I now need to think about operations to move all the numbers to the other side. So the inverse of plus 19 is take away 19. And if I subtract 19 from this side, 3 take away 19 is negative 16. If that's what 2y's is, I can work out y by finally dividing by 2. So y is negative 8. Remember, you can substitute your answer back into here. So 4y's is negative 32 plus 19. And negative 32 plus 19 sounds like negative 13. And then you can also substitute it in here. And we've got 3 plus 2y's, which would be negative 16. And altogether, that's minus 13. So just a quick way of checking that your answer to an equation is right using substitution.